Today we are going to look at climate and weather. As a topic, we must understand there is a very big difference between climate and weather. In this case, we must understand that climate is a very big section and weather is a smaller section of climate. We already see that the weather tells us, or it gives us, the climatic regions. So we need to understand that what is weather? Weather in this case is the state of the atmosphere at a particular point at a specific time, just like it is here. We look at it at a smallest period of time. For example, when we talk about weather, it's going to give us aspects like the day is sunny, the day is windy, the day is rainy. All those ones are specifically explaining the weather state of a particular place at a specific time. It cannot be throughout rainy the whole year or the whole month. So that's why we say it's a state of the atmosphere at a particular point at a specific time. So in this case, meteorologists collect the information about weather for a very big period of time, say 20 to 25 years to 35 years. So that state of weather that is collected on daily basis is the one that is compiled to form up the climatic regions. Therefore, what is climate? Climate is the atmospheric condition of a place measured for a very long period of time. So for the climate to be recognized that this area is experiencing a tropical climate, it is experiencing a savanna climate, it is experiencing a Mediterranean climate or equatorial climate, we must focus on very many aspects of weather. All the elements of weather must be collected for a very long period of time such that we can come up with the climatic regions. That's why it is a region that you look at and you say, this area is experiencing savanna, this area is experiencing Mediterranean climate, this area is experiencing equatorial. All right. So in that case, we need to know that the world or the globe has got different air pressure systems, which is basically under what you call the global air saturation. In this case, we have basically two pressure systems, and these include the high pressure and the low pressure. First of all, we need to understand what's the difference between these two. You have been hearing about the high pressure, you have been hearing about a low pressure. It's not a mere saying that it's a low pressure or a high pressure. We look at the conditions that are experienced in a place to say this place is experiencing a low pressure or a high pressure. This is the two diagrams are giving a difference. When you look at this diagram here is showing the high pressure. How do we recognize the high pressure? High pressure, air is descending. When you look at it, it is descending, but it is descending as it is rotating in that anti-clockwise direction. So it rotates anti-clockwise, descending. Now, in this case, as it descends, it simply means that we shall have a stable climatic condition in the atmosphere with no or limited rainfall, very cold conditions, and that is going to be explaining the high pressure. We also have this diagram on this other side that is depicting a low pressure. And when you look at it, air is rotating clockwise. So when you look at it, you can see clockwise, you can notice here that this clockwise movement is only evident in the southern hemisphere. And this one is also evident in the southern hemisphere. So in the northern hemisphere, it is going to be the reverse. The high pressure is going to be clockwise, the low pressure is going to be anti-clockwise. But in this case, these two diagrams are depicting the southern hemisphere. So when you see here, we say that air here is ascending, it is rising. As it is rising, it is in that clockwise direction. So what causes this to happen? You must know that during, let me say, during the summer periods, the Earth's surface is overheated by the sun. So the surface of the Earth is heated by the sun. So the air on the Earth's surface expands and it becomes unstable. That results it into rising up in the upper atmosphere. So the moist air, which is lighter, rises up in the upper atmosphere, condensing to form clouds that will result into rainfall. That's why we say, when you look at the low pressure, we say it experiences unstable weather conditions. That is a low pressure. So here is a high pressure. So in other words, at a low pressure, we must know that air must converge at a low pressure. Why? Because as air moves from a high pressure, it comes to a low pressure to fill the vacuum that has been left by the rising warm air. That's why in a low pressure, air converges. In a high pressure, air diverges. It moves from a high pressure to a low pressure. Then here, it is moving from a low pressure somewhere to a high pressure. So to a high pressure, air is diverging. As air diverges, it diverges because there is descending cold air that is going to push this air away from the high pressure. But within here, air is converging as there is rising warm air that results into air to move from a different direction to come and fill the vacuum that has been left by the rising warm air. So those are the two aspects of the low pressure and the high pressure. So we must note that low pressure has got ascending air, it has got unstable weather conditions, it is always followed with a formation of rainfall and also convergence of air into a low pressure. When you look at a high pressure, there is a descending cold air, and this cold air results into a high pressure on the surface of the earth. There is divergence, there is a stable weather condition, limited or no rainfall at all. That is a high pressure. So in this case, how do we look at the shape of the isobars? When you look at the isobars in a high pressure, isobars in the high pressure, they form the oval shape. This oval shape results into an elongated high pressure. So when the two high pressure cells are elongated, it results into a ridge. In the same case, I've talked about the air sinking. So air is sinking or descending. The air saturation is clockwise in the southern hemisphere. The skies are clear and dry conditions. Isobars increase towards the center. Actually, all these conditions that are indicated here are depicting the winter seasons. You'll find that during winter, there is descending air is rotating or saturates in the anti-clockwise direction in the southern hemisphere. Clear skies, the conditions are very dry, and so on and so forth. That is a high pressure. We move forward to a low pressure. When we go to a low pressure, the low pressure isobars form that round shape. We call it the circular shape. As it is rotating towards the center, it forms this circular shape. And then this shape in the circular shape is depicted here. Okay. Then when you look at that, air rises at the center. Air rises at center. It's not only any air that is rising, it's basically the warm air that is rising. And the reason why it is in position to rise, it's because this air is light, it's moist. Therefore, it is in position to rise as it becomes unstable on the Earth's surface. We look at the second one and say air saturates in the clockwise direction. We can also see on this diagram, this is clockwise. If you cannot see it clearly, or if you can't observe, or you can't differentiate between clockwise and anti-clockwise, you can look at a wristwatch. When you look at a wristwatch, you will see that it rotates this other side like a clock. It rotates this other side. So that is clockwise. So the opposite becomes anti-clockwise. Okay. We go back to this and say, clouds here, cloud cover and rainfall form. Which kind of cloud cover do you experience in this scenario? The cloud cover is going to be that overcast clouds, normally referred to as the cumulonimbus clouds, that is responsible for the heavy rainfall. Why does it form? These kinds of clouds will form because of the fact that there is a rising moist air. That air has got heat embedded, which you call the kinetic heat or the kinetic energy. So as it rises in the upper atmosphere, it condenses to form clouds after losing that latent heat that results into the formation of clouds, hence forming rainfall. In the same case, we shall see that isobars decrease towards the center. How do you look at this? We see that when you look at a low pressure, the isobars are going to be drawn somewhere here. The isobars are going to be drawn somewhere here. And you'll find that as you move away from the center, it is increasing. As you move towards the center, it is decreasing. Okay, those are the kind of the isobars we are talking about. And that is mainly depicted on synoptic maps or weather maps. In this case, we need to understand, we are talking about pressure, we are talking about isobars. But what is pressure, or what is atmospheric pressure? First of all, atmospheric pressure is explained as the force that air exerts onto the Earth's surface. As cold air descends, it exerts too much pressure onto the Earth's surface. And when it exerts that too much pressure onto the Earth's surface, that's why we say it is a high pressure. On the low pressure, when you look at it, the warm air is rising. That means it is leaving the Earth's surface with less pressure. That's why we say it's a low pressure when it is hot. So atmospheric pressure is basically measured with a barometer in what you call hectopascal or millbars. So if you don't find the word hectopascal, which is abbreviated as HP, as we find it as millbars, MB. That is so we move forward to understanding this global air saturation.
Please use the link below to get the notes, questions, and other videos. Don't forget to subscribe, like, and share to others for our daily new videos. Let's look at the global air circulation patterns.
So we move forward to understanding this global air saturation. In this case, when you look at this global air saturation, it is showing us the pattern, how air moves. Here we have what you call the ITCZ, which is the equator labeled 0 degrees. This equator here, it is ITCZ, standing for convergence zone. Intertropical, within the tropics, there is convergence. Convergence means coming together. That's why you see these winds, they are coming together towards this point, moving away from a high pressure to a low pressure. Remember, we said that winds move from high pressure to a low pressure, from high pressure to the low pressure. That is why the direction is coming towards the low pressure. And at the low pressure, there is convergence. But we must understand that as these winds try to move from a high pressure to a low pressure, that is what we call the pressure gradient force that results into it moving from high pressure to low pressure, which is abbreviated as PGF. But as it tries to move to a low pressure, it is being acted upon by the Coriolis force. So the Coriolis force deflects wind either to the right or to the left. As you can see here in the southern hemisphere, it is deflected to the west. To the west also here in the northern hemisphere, it is deflected. As it's trying to move from here, it is being acted upon. What causes Coriolis force? Coriolis force comes into existence because of the rotation of the Earth's surface. As the Earth rotates in that anti-clockwise direction, the winds end up being deflected. So it is deflected in that kind of manner. So as it is originating from this other side, those winds shall be referred to as the easterlies, and the ones that are coming from the other side are also, they'll also be referred to as these ones are referring to as the westerlies. So we have the easterlies as they move from the west. Remember, winds are named from the areas of origin. So they move from this as they are deflected from east going to west. Therefore, they will be known as easterlies. Okay. But it depends on the zone where they are, because we have what we call the tropical easterlies, we have what we call the polar easterlies. So the polar easterlies, they are called polar easterlies because they are moving from the east to the west, but originating from the poles. That's why we call them the polar easterlies. These ones are tropical easterlies because they are moving from the tropics. So this global air saturation, or this globe, is divided into sections. We have the intertropical convergence zone, the ITCZ. We have the subpolar high pressure cell. We have the subtropical high pressure. Then we have the subpolar low, and here we have the polar high. In other words, it is a halo. It is a H, L, H, L, H. So it will be high pressure, low pressure, high pressure, low pressure. So when you talk about low pressure, you remember that low pressure, we said air is rising, okay? But that is warm air is rising here. Then here, air is descending. Here, air is rising. Here, air is descending. So we know that at the poles, air is, it is experiencing very cold conditions. And therefore, that is what we look at as high pressure, low pressure, and so on and so forth. So here I've incorporated the element of the pressure gradient force, the Coriolis force, the wind's diffraction, and then the movement of winds from one point to another. Winds just don't move. They move or they blow because of the fact that there is difference in pressure. So the difference in pressure is what we call pressure gradient. But the force that results into winds to move from high pressure to low pressure is called pressure gradient force. Okay, hope you understand. We move forward. We have said that at the equator here, we know that it is very hot. Why? Because as the Earth tries to rotate around the orbit, the sun will appear twice at the equator, which makes it hotter. And therefore, within the equator, we know that there is ascending air, and therefore the pressure is low. Okay. Then we go to look at the high pressure. At the high pressure, what happens here? The air is moving from where? From the equator, and it sinks to the high pressure here. So as it is moving from the equator, reaching here in the upper atmosphere, it sinks here. So in the same line, when it moves from here, coming to the low pressure, reaching at the low pressure here, the subpolar, it rises. That's why we say it's rising air. So here at the poles, it is very cold. What happens there? Air is descending, and therefore it's a high pressure. In the same scenario, here we have warm and cold air meeting at a low pressure, the subpolar, or we call the polar front. What is going to happen here is that we have got the polar easterlies from the poles, which is very cold, and we have also got the westerlies from the subtropical high, which is a little bit hot or warm. And therefore, those two air masses that are of different characteristics are coming to converge here at a low pressure. And on converging, what happens? Warm air will be forced to rise. That's why we say warm air meets here. But you must understand that when air meets, it does not enter into each other. It meets, and therefore the intensity of the cold air forces the warm air to leave, and then it rises up in the upper atmosphere. So we said that the winds that are found here within this region are westerlies. Why? Because they travel from west. The same way, this is in the northern hemisphere, this is in the southern hemisphere, remember, as of origin. Therefore, we also have the easterlies. We call them tropical easterlies because of the fact that they are originating from the tropics. But because of the rotation of the earth, this wind is acted upon by the Coriolis force. Therefore, it is deflected to the west, but coming from the east. Therefore, we call them easterlies. The reason why we call them easterlies because the reason why we call them tropical easterlies because they are originating from the tropics. So that is why we name them as tropical easterlies. Then you must note that winds are deflected to the right in the northern hemisphere, to the left in the southern hemisphere. Okay, that is what happens. If you will forget this, you try to draw letter S here. When you draw letter S here and you cross the equator coming down, you are starting drawing S here, coming down here. Note that the low pressure in the northern hemisphere is rotating anti-clockwise. As you're trying to draw S, you start like this. When you cross the equator coming to the southern hemisphere, it starts rotating clockwise. So we know that a low pressure in the southern hemisphere rotates clockwise. Okay, that is it. So we move forward to now our first topic. The moment you understand the basics of this global air saturation, which we looked at in grade 11, then this will give you a firm foundation for you to understand the next topic, or a very important topic that is greatly examinable, and that is what we call the mid-latitude cyclones. What do we understand by mid-latitude cyclone? Like the name mid-latitude cyclones. We quickly go back and look at this. Okay, it's called mid-latitudes. These are latitudes. These are latitudes. These are latitudes. What are latitudes? Those are imaginary lines that are drawn from west to east, increasing. In the northern hemisphere, it increases to the north. In the southern hemisphere, it increases to the south. When you look at these lines, you draw this, you draw this, you draw this one. So when you look at it, we have this segment here and we have this segment. Where is the mid? The mid is here. So this one is the mid area of the southern hemisphere. The same way in the northern hemisphere, we have this segment here. We also have this segment. This is the mid. So that's why they call it mid-latitude cyclone, meaning that it is basically occurring between the mids of the latitudes. So it is occurring between 30 and 60, north and south of the equator, the same way north of the equator, the same way 30 and 60, south of the equator. Okay, so it's called mid-latitude cyclone. But you must not forget, learners, that mid-latitude cyclones are also known by different names. For example, it is known as a temperate cyclone. Okay, it is known as frontal depression. Okay, extratropical cyclone. Sometimes we miss that one mark in the exams because you're forgetting those simple names. But let us look here. It's called mid-latitude cyclone as it is found within the mid of the latitudes. And the cyclone is basically low pressure. When you go back to this diagram, you are going to find out that we said the mid is here. And this is where you have a low pressure. So it forms here at the subpolar, basically at 60. The same way here, it is here at the subpolar at 60. Okay, that is where it is found. But what is going to happen? That it forms because we have got the westerlies and we've got what? The easterlies from the other side. Remember, this one is called the polar easterlies, and this one is called the westerlies. These ones are warm as it is coming from the subtropical. These ones are cold as it's coming from the poles. Okay, so we must note that cold and warm fronts here exist at the mid-latitude cyclone. What you must note that when talk about mid-latitude cyclone, the first thing that should come into your mind or in your head is that cold front and the warm front. How do they exist? That will be the next thing we are going to look at. So we are going to look at the cold and warm front. We are going to look at the stages and the weather changes that come in or that exist because of the cold front. So here we go. What we must note that what is a mid-latitude cyclone? What does it mean? You must understand. We say that it forms 30 to 60. You must understand that mid-latitude cyclones are low pressure systems. It is a low pressure system. If you must note that it is a low pressure system that develops in the westerlies, traveling from west to east. Sometimes I always want to add on that it develops because of the polar easterlies and the westerly winds. Okay, so you must know that it's a low pressure system that develops in the westerlies, okay, and it travels from east to west. You must understand, why is it traveling from east to west? It is traveling from east to west because it is part of the westerlies. Remember we said that westerly winds, what happens to the westerly winds? They travel from west to east. Since it develops here between 30 and 60, and these winds are moving from west to east, so the cyclone itself is also going to travel from west to east. That's why we say it develops within the westerlies, traveling from west, to east. You understand? The same way here, it is between 30 and 60, traveling from west to east, as it is part of the westerly belt, which is moving from west to east. Okay, what are the characteristics? What can you look at? What features can you tell? Or what can you look at to say this is exactly a mid-latitude cyclone? Please, learners, understand that the characteristics clearly tells us that this is a tropical cyclone, this is a mid-latitude cyclone, and so on and so forth. Therefore, since we are looking at a mid-latitude cyclone, what happens here? It has got two air masses, that is cold and warm front. It has got two air masses. These air masses results into the development of different fronts. Remember, we said that one air mass is coming from the polar regions, which is cold, and there's another air mass that is coming from the subpolar region, which is the westerlies, and it is warm. This results in the development of us having warm front and the cold front. In other words, when you look at mid-latitude cyclone, you know that we shall have the cold front and the warm front developing. Therefore, we also note that since it is known as a low pressure, remember when we are looking at the first thing that we looked at the beginning, we said low pressure decreases towards the center, and therefore pressure must drop below 1,000 hectopascal. We said hectopascal are the SI units of pressure, which is measured on a barometer. So pressure at the center is always below 1,000 hectopascal, decreasing towards the center. That's why it's called a low pressure. And it also says it forms all year round, but it affects Western Cape in winter. We know. Why do we say it forms all year round? Remember, this system, it moves with the apparent movement of the sun, or the ITCZ. What happens is that if it is winter in the southern hemisphere, the system moves close to South Africa. But if it is summer in the southern hemisphere, the system is forced to move further away from South Africa. That's why we say it forms throughout the year. The only fact that it only affects South Africa only during winter, but it is occurring throughout the year. All right. Then we also say that it occurs between 30 and 60. We have noted it. It's a mid-latitude cyclone, midway. The mid is here and the degrees are here. Latitudinally, it is located between 30 and 60 north and south of the equator. We go ahead and say the other names. Like I said, it's known as a temperate cyclone, frontal depression, a wave cyclone, extratropical cyclone, and so on and so forth. So those are the names that can be used to refer to a mid-latitude cyclone. Okay. Now, we must know that it does not occur once. A mid-latitude cyclone takes stages. It occurs in different stages. The stages, the first one, that's as the first stage, is what we call the initial stage. Remember on our diagram, remember this way we are going to focus specifically or mainly on South Africa. And in South Africa, we know that the cold air, or in the southern hemisphere, the cold air is in the south, the warm air is in the north. And these two air masses are coming from different directions. Okay. So the point here where the air masses are going to meet, or they are going to converge, is what we call a polar front. But what you must note that the pressure in the initial stage is still high. Because the cyclone is just starting to develop, the pressure is still above 1,000 hectopascal. That's why you see close to the boundary zone that is separating the two air masses, pressure is still above 1,006 hectopascal. We quickly go back to the diagram. I will basically use this diagram so much. When you look at this, let us first of all ignore this other northern part. Let us look at the southern part. When you look at the southern part, this is the southern hemisphere. We know that there is air that is coming from this other region, which is the polar easterly, and its meeting point is here. So as it is coming from the poles, this one at the bottom is going to be cold. We have this one that is coming from the subtropical. So since this subtropical is close to the equator, it's a bit warmer compared to the poles. Therefore, we have the northern part which has got warm air. So we have the warm air and we have the cold air. Remember, this one is coming from this way. It's meant to go the opposite direction. And this one is meant to go the other direction. So this one is called easterlies. So because it is called easterlies, it moves from east to west. Therefore, it is meant to be moving like this to the other side. And this one is meant to be moving from the west to east. Therefore, it is moving like this. So it's just bypassing each other at the subpolar low pressure here. So in that case, the way it is here is the way it is reflected the other side. Warm air above passing from, remember, it is westerlies from the west going this other side. These are the easterlies from the east going this other side. That is the initial stage. What you must note with the initial stage is that it is sometimes referred to as a stationary stage because boundary is not moved at all. Okay, that's why we call it the stationary stage. We go to the second stage. The second stage is also known as the developing stage or the development stage. In other words, some other books will call it a wave stage. In this case, pressure starts to drop and a wave develops. And therefore, the rotation of the wind at a low pressure it starts, and therefore it rotates in that clockwise direction. Remember, we are looking at the southern hemisphere. We said in the southern hemisphere, air circulates in that clockwise direction. That's why the arrows are pointing in this direction, southwards. Therefore, this is the northern part. This one is coming from this way. This one is coming from the east, and therefore it is rotating at a low pressure that is starting to develop in that clockwise direction. And in this case, a wave develops, and you will see that the fronts are also starting to develop. Okay, and at the apex, the pressure is dropping to below 1,000 hectopascal, but it is still high. So we got another stage, which we call the mature stage. In the mature stage, pressure drops further below 1,000 hectopascal. So therefore, here it's going to be below maybe 984 hectopascal. A cold front and a warm front is visible at this stage. So what happens here? How do you notice that this is a cold front and this is a warm front? A cold front is represented with a triangle. Okay. A warm front is represented by a semicircle. So what happens is that behind a cold front is a cold sector, and behind the warm front is a warm sector. What you must note that this cyclone is moving from west to east. So it's going into this direction, while the air is circulating in that clockwise direction. As it is rotating, the sectors of warm sector and the cold sector becomes clearly visible, and therefore, because it is visible, the warm sector is developed here. It is behind the warm front. So this is the warm front here, and here is the cold front. Therefore, behind it is the cold front. The whole of this sector here is the cold sector. Okay, so the air behind the cold sector is cold, and the air behind the warm sector is warm. What we must note that this is a mature stage, and in the mature stage, cold front and warm front are visible. They are easily identified. Okay, we got the next stage, which we call the occlusion stage. So in this occlusion stage, we must understand that cold air is heavy and denser. Therefore, it moves faster than the warm air. This is going to force the cold front to catch up with the warm sector, narrowing the space that was occupied by the warm sector, as it is pushing the warm air outside the cyclone. So meaning that as this one catches up with the warm sector, we are going to see that at the apex, the two symbols are going to be represented. So these two symbols that are represented, there is a symbol for the warm front and a symbol for the cold front. A triangle is the cold front. The semicircle is, the triangle is the cold front. The semicircle is the warm front. Therefore, this is what we call the occlusion front. So in this occlusion front, in this stage, the occlusion, it results into the development of the occlusion front. So we have the cold air behind the cold front. In the cold sector, we have the warm air in the warm sector that is behind the warm front. And this is what we call the occlusion stage. Then, in this case, when you look at these two stages, there is a characteristic that we did not mention. That characteristic that we didn't mention is that mid-latitude cyclone occur in families. We have them occurring in families. That is, there is one here, there is this one here, there is this one here. What is a family of a mid-latitude cyclone? These are series of mid-latitude cyclone. And when you look at it, it is moving from this other side of the west to the side of the east. Remember, we have a high pressure here, and we have a high pressure here. Sometimes this high pressure is also known as a blocking high. It is blocking this cyclone from going into the other side. So that will force it to move so that it can move this other side, but still in the westerly direction. So what we must understand that the cold front on this other side, there is also a cold front here. There is a cold front here. There is a warm front here. It is moving from this other side to this other side. If you notice, let me say this one is A, this one is B, this one is C. Of the three, which one is mature? it's going to be that this one, A, is going to be mature. Why is it mature? Because this system is moving from west to east. Therefore, it simply means that even this one was once in the west, but because it is moving the other side, it is moving in that direction. Actually, this one is depicting almost the stages. Here, it is the initial stage, okay, when it is just starting to develop. Actually, this one could be the developing stage when it is just starting to, a wave is just starting to develop. Then this one is the mature stage. You can see that a cold front and the home front is visible. And here you have the occlusion stage, meaning that as you move away from the west to the east, the cyclone, the stages are starting to develop. And therefore, there is a last stage, which we call the dispatch stage. Okay. The last stage will be called the dispatch what? The dispatch stage. What happens that as warm air is pushed away from the ground is going to be only occupied by the cold air. So that means the cyclone starts to die. So this one is what we say the developing stage. This one is the mature stage. This one is the occlusion stage, as it is indicated by the symbols on the diagram. Okay, so the whole of this is called a family of a mid-latitude cyclone. All right, now we must note that the occlusion stage has got two fronts. Okay, we have the warm occlusion front and the cold occlusion front. But the warm occlusion front has got the characteristics of the warm front. And the same way the cold occlusion has got the characteristics of the cold front. This is how the warm front is going to look like. What will happen that when you look at this line is gentle, okay, which is a bit different from this one. When you look at this one is stiff. This one is gentle. What happens is that as warm air reaches this point, it is forced to rise. And it is rising at this point, meaning that if these two are put together, one is here, another one here, the warm air is going to rise. And therefore, as it rises, it is going to result into the formation of clouds here, just on the cold front. So these clouds will result into the formation of heavy rainfall, and therefore heavy rainfall will be experienced on the cold front. But here we have got some kind of clouds that are going to develop. Actually, I normally use the word CAN, which is cirrus clouds, altostratus clouds, and nimbostratus clouds. These are the clouds that develop here. When you look at the shape of the clouds here, they are light and a little bit growing longer. Why are they growing longer here along the warm front? Is because of the fact that this wind, there is also some air that is moving along this, which results into it to be lengthened along the warm front. But these kind of clouds, cirrus clouds, nimbostratus clouds, and altostratus clouds. But here you can see that it's a very long cloud that is growing taller with a very flat base. So these kind of clouds are what you call the cumulonimbus clouds, and these cumulonimbus clouds are basically associated with the following weather conditions, like heavy rainfall, lightning, thunderstorms, and at times hail. So that is what we refer to as the cold and the warm front. So those conditions are going to be prevailing there. So this is how a mid-latitude cyclone will appear in the mature stage. Okay, you can see the air rotating in that clockwise way. You can see the cold, you can see the warm front. These lines here are called isobars because of this hectopascal. And then this one is called the cold front that is prevailing here. Remember, we said the cold front basically is represented by these triangle symbols. Then we also have a warm front on the other side. If you see critically, you'll find out that this warm front and the cold front are represented by different colors. Remember, warm, it's going to be red, it's a bit hot. Then cold is blue because it is colder. But what is a cold front? By the way, we're talking about cold front, we're talking about warm front. What's a cold front? A cold front is just going to be a parcel of cold air that is going to be separating the warm sector from the cold sector. It's going to be cold air along, In other words, the edge of cold air that is pushing towards the warm sector. Then we have the warm front here. So it's going to be a parcel of warm air, okay, that is in front of, or that is pushing towards this other side. So it's going to be a warm sector, a warm front. So this is a parcel of warm air, and this is a parcel of cold air. So in the center, it's a low pressure. As pressure drops further down below 1000 hectopascal. Okay, these arrows, we said it is representing the rotation of the saturation of air or the rotation of a cyclone, and we said in the southern hemisphere it is rotating clockwise. So the whole of this sector here that you see that it is shaded with the red line or red lines is going to be the warm sector. Then the whole of this sector at the bottom that is shaded with that kind of color is the cold sector. So the cold sector is covering this whole section, and the warm sector is covering that whole section. So that is basically explaining what we call the stages of a tropical, of a mid-latitude cyclone. Hope guys we are understanding each other and we are moving at the same pace. Okay, so now we must understand, before we even move here, we must know, I must explain this to you, that what happens when this cold front passes, okay, or what happens when we reach the occlusion stage. You must know that when you reach the occlusion stage, the ground is going to be forced, the warm air is going to be forced to move away from the ground, and therefore the ground will be basically occupied by cold air, and therefore what will happen? The air temperature is going to decrease as the cold air is basically passing. In the same line, we shall see that the air pressure is also going to rise. It's going to be a high pressure, and therefore we shall experience stable weather condition at that particular moment. So we need to look at this. This is a synoptic weather map, and I want us to look at it and critically to see that what weather changes are caused by the cold front. Look at that. In this case, on this weather map, we have to be analytical and analyze a lot of things. When you see this weather map, look at the isobars here. The isobars are far away spaced from each other. So because the isobars are having a very big space as we're moving away from each other, it means the pressure gradient is weak. But when it is like this, when they are so close, we say it is a steep pressure gradient because isobars are so close to each other. What is the implication of this? It simply means if the pressure gradient is steep, the wind speed is going to be very high. Here, the wind speed is going to be very slow. Okay, this is the cold front here, and therefore we also have the warm front there. In the same line, we have these northwest winds. Look at this. These station models are showing us the wind direction. From the station model, it is in the northwest direction. Therefore, we say the wind is rotating in that northwest direction. Then we also look here that as it is coming here, it is in the southwest direction. As you see, it's indicated by the station model. So hope guys you understand what we mean by station model. Station model is just a symbolic element or a model that is used to explain the weather conditions that are experienced. So within here in the warm sector, the wind is moving in that northwesterly direction as it is depicted here, but here it is moving in the southwesterly direction as it is indicated there. Okay, so in that case, we have understood this. So we can see, remember in our previous map, synoptic weather map, we showed what we mean by families. These are the families whereby it is existing in series. So there is one here, there is one here, moving in this westerly direction. And you must note, we said also that cold front affects Western Cape during winter. What depicts the winter season here is that we have got a high pressure in the interior here. Okay, there's a high pressure here in the interior, which shows that it is winter in the interior here. So we can also look at the cold front, it approaching Western Cape. It approaches Western Cape basically during the winter season. But remember, we said it occurs throughout the year. Therefore, what happens is that it's winter. It is close to South Africa. And therefore, if it is summer, it will move far away, further south, away from South Africa. Okay, so we move forward. We need to understand now some of the examinable questions or some of the questions that are likely to be set. What have we looked at? We have looked at all those ones. We have looked at the cold front, the stages of the development, the initial stage, development stage. We have looked at the weather conditions that are experienced when the cold front has passed, and so on and so forth. So we need to see if they tell you to describe the weather conditions that are experienced here. What do we use? We use the station model, and this station model is clearly depicting the conditions. You see here in the warm sector, the wind direction is northwest. Here we say it is southwest. Okay, this number above here is the air temperature, which we could say that the maximum temperature. Therefore, the maximum temperature within the warm sector is 24. Here, the minimum is 15. Here, where we said that this zone here is a cold sector that is occupied by cold air. Therefore, you can also look at this and you see that this one is 16, this one is 14. This way is a bit colder than what will happen here. So at the warm front, temperature rises to the maximum. Okay, so that's why you see the warm temperature, the temperature here is 24.